Hello, everyone. Today I'm going to give you an introduction to EMQX Serverless, and then I'll give you a quick demo to show you how easy it is to set up. And then after that, Dimitri will give you the technology behind how it's built. So EMQX Serverless is a high-performance MQTT broker in the cloud. So it's convenient because you do not need to run, you do not need to have your own server or spin up any containers. It's fast deployment. You can create your service in just a few seconds. And it's true pay as you go because you pay only for what you need. And you can also set a maximum limit so that there's no unexpected costs or surprise costs at the end of the month. So the pricing is based upon session minutes and data traffic. And every month you get 1 million session minutes free. And also for free, you get 1 GB of data traffic per month. And we count one session minute as a single client that's connected to the broker for 1 minute. Basically, that's it. But MQTT does allow a client to tell the broker, hey, please keep my session alive even when I'm disconnected, so that you can queue up messages that I would be missing otherwise, and please deliver those to me when I reconnect. So in MQTT, that's called a persistent session. So persistent sessions are also counted. So now I'll explain the difference between EMQX Serverless, EMQX Managed Cloud, and EMQX Self-hosted. So EMQX Self-hosted has two products, EMQX Open Source and EMQX Enterprise. So both of these are high performance, fully 100% MQTT compliant message brokers. And both of them have a rule engine that allows you to process messages in real time. So you can actually do computations on the messages that come in. And EMQX open source, as the name implies, is open source. It's completely free, and it has a really nice user-friendly dashboard for monitoring the broker, so you can see all the statistics that are going on in the broker. EMQX Enterprise is based upon EMQX open source, but it's a licensed product. And what it has is an enhanced rule engine that allows you to forward data to many backend systems, such as popular databases, such as MongoDB, MySQL. You can forward data to message queues, such as Kafka. And EMQX Enterprise also comes with either 8x5 or 24/7 support. So next I'll talk about EMQX Managed Cloud, the dedicated option. So the dedicated option has two plans, the standard plan, which is based upon EMQX open source, and the professional plan, which is based upon EMQX Enterprise. So because it's based upon EMQX Enterprise, it has all of the backend data integrations that allow you to persist data to databases, and to forward messages to message queues such as Kafka. And shown here is the professional. And as you can see that you can choose your own cloud provider. You can choose your region where you want your data center to be. And you can also choose a block of how many connections you want, such as 1,000, 5,000, 10,000, etc. So that's the professional plan. So if we compare EMQX Serverless to EMQX Enterprise, EMQX Serverless is based upon EMQX Enterprise version 5. It's multi-tenancy, and there's no restrictions on the topic name. So even though two tenants may want to use the same topic name, that's no problem because they'll each have their own independent topics, even though they share the same name. Um, It has transparent namespacing based upon SNI or server name indication. And as you can see here at the bottom, it allows you to limit the amount of spending that you'll be charged per month. So you can set that to exactly what you want. After the broker is spun up, this is an example of the address that clients will use to connect to the broker. Clients connect over TLS, so either secure MQTT using port 8883, or they connect over secure WebSockets using port 8084. So most of the clients probably will have the root CA that's used, but if not and they need it, if you click on this icon, you'll be able to download the root CA so that the clients can verify the certificate from the broker. And so this just shows that the client hello packet in the TLS handshake, that the broker address is in the SNI field. So if we compare EMQX Serverless to EMQX Cloud Dedicated, EMQX Serverless is much faster to get up and running. The pricing is at a much finer grain level that rather than large blocks of tiered connections, which can be, so serverless can be more cost effective for unpredictable connectivity. For instance, if you have a large peak spike of connections that lasts for kind of a short period of time, then that would be much more cost effective than maybe the dedicated. Um, and it's also a shared cluster with other tenants, so it may be more suitable for small businesses. So if we look at the pricing model of serverless versus cloud dedicated, EMQX Cloud Dedicated is based upon large tiers of connections and transactions per second. So for instance, you can choose 1,000 connections, 5,000 connections, 10,000 connections, etc. In large blocks. So in this example, I have, in this example, we've chosen 1,000 connections and 1,000 messages per second, and that would be at a cost of around $260 per month. And you also pay for the outbound data over the free limit. But maybe you don't need 1,000 connections or 1,000 transactions per second. Maybe your requirement, your use case is much lower. So with EMQX Serverless, you can set this to, say, the number of connections to be 123, and maybe the connections are only publishing, instead of once a second, they're publishing once per minute. And the payload is really small, maybe a couple hundred bytes. So in that case, the cost would be about $8.50. So you can see that's quite a cost savings compared to what you would have to pay for cloud dedicated. So you can also estimate your monthly usage using our pricing page on our cloud pricing page. So you specify the number of connections you have, the average number of connections, the average message rate per minute, and then you specify the message size. So with these numbers, that comes up to about $7.60. And if you want to calculate this yourself, this is the number of messages per month, the number of minutes per month based upon a month of 30 days. And keep in mind that 1 gigabyte is 2 to the 30th, and that's this number, not an even 1 billion. So in this example, the number of session minutes would be 50 connections times the number of minutes per month. And the data traffic would be the number of connections, which is 50, times the message rate, which is 60, times the message size, again, times the number of minutes per month. And then you would calculate those and then subtract the free quota, which is up here. And then you would get a calculation, a pricing for both of those separately. So you should come up with about $2.32 for the session minutes and $5.28 for the data traffic. And if you add them up, it's $7.60. So next, what I want to do is give you a demo to show you how easy it is to set it up. So the place to start is emqx.com. And if you press Start Free, you'll come to this page. And this page allows you to try any of our products for free. But since we want a cloud product, we select EMQX Cloud and then Get Started Free. And so once you sign up, you'll land on this page. And if you select Serverless, Start for Free, notice that you can here you can specify the amount that you're willing to spend over the free amount. So we'll say $1. And then you have a choice. Basically, the choice is what happens when that session minute limit is reached, or the dollar amount is reached. You can decide to either suspend the deployment, where it will stop and will not be able to accept any connections, or you could say, no, I want to keep my broker running and actually go over the limit, but please remind me that I've gone over the limit. So once you make your selection and you hit deploy, then you accept the cloud license agreement, and then basically it's up and running. So you'll see that it doesn't take very long to set up. And the one thing we'll have to do is we'll have to provide credentials for our clients to be able to connect. So already it's up and running. So we have our broker. So this is the address that the clients will use to connect. So I'm going to copy that. This, if you need it, is the root CA. And you can also adjust at any time the amount that you want to pay over the free limit. So I've copied the address. So the one thing I'll have to do is add a credential so a client can connect. So I'm going to say user, and I provide a password. So now I've got a username password where the clients can connect. So the tool I'm using for my clients is our product MQTTX, and I've got 3 different clients here. The first client will act as a sensor, and it will publish its data. This is its data payload that it will publish to a topic called Sensor1 Data. And then I've got 2 clients that are both subscribing to the Sensor1 Data topic. But there's one thing that's different between the clients. So let me explain that. So if you notice, if you look at the clean start flag, for this client, it's set to true. And for this client, it's set to false. And the difference is when the clean session flag is set to true, basically that tells the broker to forget about me after I've disconnected. So you connect with the clean session equal to true. And then that tells the broker, please forget about me when I disconnect and don't care about my subscriptions. But this one, with the clean session equal to false, that tells the broker to please remember me. When I disconnect, please remember me, and please keep track of all the subscriptions that I've subscribed to. So now let's connect these. So the one thing I'll need to do is add the broker address that I copied. They're connecting using secure MQTTS, and I've already included the username password. So hopefully that will connect. I'll do the same with the others. I'm adding in the broker broker address, and then finally the last one. So now I've got my 3 clients connected, and let's go look at the broker. So I can see here here's my 3 clients, the sensor, the one I called Forget About Me, and the one I called Remember Me. And they're both subscribing to the sensor one data topic. And if we look at the overview page, we see that we have 3 sessions. We're using 3 sessions out of, we're allowed 1,000 sessions. So we're using 3 of our allowed sessions. And then since we just started, we don't have really any session minutes, but this will keep track of your session minutes and the traffic that you're using. So you always know at any one time how many session minutes you've used and how much traffic you're used. So let's go back to our clients. And now if we publish, again, to sensor one data, we can see that our clients are receiving the messages. So this one, we can see it receive the messages that were published. And we can see that this client has seen the received the messages. So now let's disconnect those clients. And what I'm going to do is clean it so that we start with a clean slate. So notice both of these clients are disconnected, but if we go to the broker, we can see that the broker still has 2 sessions, and you can see it here, 2 sessions. Oops. And that is because the one that we said, remember me, the broker knows it's disconnected, but it still maintains its session. And more importantly, it maintains its subscriptions that it's been subscribing to. So what's going to happen is the broker will queue up all messages that would go to this client, the one I labeled remember me, and when it reconnects, it will deliver those messages back to the client. So let's try that. So with these disconnected, sorry, let me publish some, let me clear this. So everything's clear. I'll publish some messages. And of course, both these clients are disconnected, so they're not going to receive anything. But let's see what happens when I reconnect the clean session client. So if I connect it, so the client's connected, but nothing happened. It didn't receive any messages because basically the brokers forgot about all the subscriptions that it had subscribed to. But now let's compare to the persistent session client, and have it connect. And notice that it's received all of those messages that were published while it was offline or unconnected. So that's the whole reason why you would use a persisted session. So now I'm going to hand it back over to Dimitri to talk about the technology behind the serverless cluster.
Thank you, Karen. So when speaking about the technology behind the serverless, the most important part is our technology going to scale horizontally to support thousands or more of tenants. The EMQX team put a lot of effort in improving and verifying our horizontal scalability, and I will briefly talk about our results. Real highlight of MQTT protocol is its flexibility when it comes to the topics. Unlike other message brokers, such as Kafka or Pulsar, MQTT topics are dynamic. They need not to be created in advance by the administrator. It's common to have a few topics per client, which brings a lot of benefits. For example, it's possible to fine-tune access control for the clients on the topic level, to increase the parallelism when processing data, and improves the throughput of the system overall, just to name a few. And of course, it's possible to use wildcard subscriptions to receive data from multiple topics using a single request. I would say this feature to MQTT is what select statement is to SQL. All of this makes lives of application developers easier by moving complexity to the broker. Therefore, when it comes to scalability of MQTT broker, the ability to handle millions of topics and wildcard subscription efficiently is the golden standard. EMQX team put serious effort into optimizing and benchmarking this particular use case because it's a high-hanging fruit. So let me give you a very high-level overview of how EMQX cluster handles wildcard subscriptions. First, suppose we have a broker cluster with 2 nodes. These nodes run an embedded distributed database called Mria. Since Mria runs in the same address space as EMQX and it supports in-memory tables, querying data from it can be as fast as accessing a local variable. On top of that, it also supports atomic, consistent, isolated transactions, much like Postgres or other client-server databases. This also helps us to replicate data written to the tables between nodes in the cluster. There is a dedicated network channel used for replicating Mria transactions and other EMQX signaling traffic, and it's completely separate from the network connections used for forwarding MQTT payloads. With this unique set of features, Mria is a perfect database to store routing information in EMQX. EMQX router uses a few Mria tables to store information about topics and subscriptions. Now let's see what happens when the client connects to node N1 and subscribes to a wildcard topic. Node N1 inserts an entry to the database, and it looks like this. It contains the topic and the destination node. There is also topic tree table, not shown on this picture, with the components of this topic. Mria then takes care of replicating this data across the cluster. So when another client connects to the different MQX node N2 and publishes a message to a topic matching the filter, N2 knows that it must forward this message to N1, where it can broadcast it to the local clients. As I mentioned previously, read-only queries in Mria are very fast, since all the data is read from a local in-memory replica of the table. But writes have to be replicated over the networks to each replica, and therefore they can become pretty heavy, especially in a cluster with a large number of nodes. Prior to EMQX 5.0, this sometimes became a problem, but EMQX 5.0 we've solved this problem by redesigning Mria database to make sure write queries are extremely fast too. Thanks to this optimization, we can handle tens of millions of wildcard subscriptions, as proved by our benchmarks. Let's take a look at how this problem was solved. Mria is an open source extension to a Mria database developed by EMQ that adds eventual consistency to the clusters. Most of the features that I mentioned earlier still apply to it. The difference is in how data is replicated between the nodes. Mria used full mesh peer-to-peer topology where every node in the cluster was equal and could initiate write transactions that had to be replicated to all peers in the cluster synchronously. Mria switched from a full mesh topology to a mesh plus star topology. Each node assumes one of the 2 roles, core node or replicant node. The behavior of a core node is the same as that of Mria nodes in EMQX 4.x. Core nodes form a cluster in a fully connected manner, and each node can initiate write transactions, hold locks, and so on. Therefore, EMQX 5.0 still requires core nodes to be as reliable as possible in the deployment. Since all core nodes participate in our two-phase commit protocol and hold an up-to-date copy of the data, Mria retains much of the same fault tolerance guarantees. If one or several core nodes go down, the cluster does not lose any data and continues running. Replicant nodes, on the other hand, are no longer directly involved in processing of transactions. They connect to core nodes and passively replicate data updates from there. Replicant nodes are not allowed to perform any write operations on their own. Instead, they delegate such operations to one of the core nodes. But since the replicants still have the full copy of the data, there's no performance penalty when it comes to querying the topic tree and EMQX route tables. Additionally, transaction replication for different sets of tables are not logically related on the application level is handled independently. Such groups of tables are called shards, and it helps with latency and throughput. So what can be achieved with this new architecture? We run a large-scale benchmark to see how large of an EMQX cluster we could create and how many clients it could handle. We used 20 replicant nodes that accepted MQTT traffic and 3 core nodes that only served Mria, and 17 load generators to connect 100 million clients to a cluster. Half of the clients were publishers and other were subscribers. In this benchmark, we tried to make things as difficult as possible for EMQX to make sure the results are applicable to the real world. First of all clients subscribed to wildcard topics rather than concrete topics. Each publisher created a unique topic, and each published message had to be routed to a unique subscriber. This topology was chosen to make sure EMQX router has to handle as many topics and as many wildcard subscriptions as possible. To validate our optimizations in Mria paid off. Each EMQX node handled both subscribers and publishers, but they were distributed across the cluster in such a way that makes sure that all the messages have to be forwarded between the broker nodes over the backplane network to make it the absolute worst case scenario for the broker cluster. Payload size was 256 bytes. Test lasted for several hours to make sure all the clients had published some multiple messages or pings. Here you can see a screenshot of EMQX dashboard taken on one of the nodes during this test. It was taken on one of the core nodes, which, as I mentioned, only handled Mria traffic and did not take any MQTT connections. So what were the results of the test? The EMQX cluster managed to handle over 100 million total connections, 50 million unique topics, and 50 million wildcard subscriptions. We reached throughput of 1 million incoming messages per second and 1 million outgoing messages per second, or 2 million messages per second in total. Network traffic sustained was 288 megabit per second per node, or 4 gigabit per second in burst per node. But we did not reach the limits of EMQX. To summarize, maybe a business does not need 100 million clients just yet. But this is the technology that is powering EMQX Serverless. So our multi-tenant cluster is very capable. And if you grow out from serverless, EMQX has options to support on-prem setups as well. Right, that's it for my part. Let's move on to Q&A.
All right. Thank you, Kerry and Dmitry. We have collected a few questions already. Some are answered already in the Q&A box, so we're going to address it now again. Question number 1, can we change WebSocket port number from 8084 to 443 as the default HTTPS endpoint? And this answer is not a yes or no, but it's a good idea. I will take it to the ops team. We can maybe, since the services host is the endpoint is provided by a load balancer, so there's no reason for us not to enable 443. Maybe we can even enable both. But I have to take it to the team to see how they say it. And another question is the billing amount difference between MQTT or MQTTS or the transport layer? The answer is no. The billing is only calculated from the session minutes. It doesn't matter which transport you're using. By the way, all the transports are secured, so there is no plaintext HTTP WebSocket or no plaintext MQTT. It's either MQTTS over TLS or WebSocket, secure WebSocket over HTTPS. And question number 3, what does it mean that EMQX will suspend the deployment when I run out of session minutes? Can you explain how EMQX handles that situation? Kerry, can you answer that?
Yeah, I can answer that. So what happens when you reach the limit is that basically it stops. So you are not allowed to accept, clients can no longer connect to the broker. But at the end of the billing period, at the end of the month, at the new billing period, then it restarts again. So it's going to basically stop the broker where it can no longer accept clients until the new billing period starts at the beginning of the month. So then it basically everything is reset. So it will start up again.
Okay. Thanks. Next question is, what other features are on the roadmap for EMQX Serverless? Can you provide any insights into the roadmap? I can answer some. So currently we only provide EMQX MQTT message routing, message broking. There is no integration with databases or other messaging platforms yet. So the next feature that we are going to add is to have the enterprise EMQX Enterprise rule engine supported in our serverless offering. So you'll be able to trigger a webhook, for example, or when the message arrives on a certain topic. or forward the message to Kafka. And then there is also extension of authentication, which is also in the roadmap. Yeah. Stay tuned. There will be more. I don't have the complete list at the top of my mind. Then the next question is, if my business grows over 1,000 connection limit, session limit in serverless, what happens? I guess it's more of a question about migrating, service migration. When your connections, the number of sessions grow over the limit, it's time for you to probably consider deploying your own dedicated service in the EMQX Cloud. And then there will be a user credentials export feature, so you can export the username passwords, or the password hashes actually, to locally, and then you can import it into the dedicated cloud cluster. This will start off as a manual step, but there is no reason for us not to automate it if there are many customers asking for this feature. That means if you have a deployment in MQTT in serverless, and then you create another cluster as a dedicated cluster, and then you ask EMQX to the EMQX Cloud Service to import all your credentials from this deployment to the other deployment. That's totally doable. Yeah, that's also something we're going to add in the roadmap, which I forgot for the last question. And there is one last question from an anonymous attendee. Do you provide it in firewall for sessions? I'm not quite sure what is this about. When it comes to security, as I said, we only allow secured clients to connect, like MQTT over TLS or over secure WebSocket. And then there will be your own namespace username password for authentication, for client authentication. But it's wide open to the internet, if that's your question. Yeah, the service endpoints are wide open to the internet, so you can all clients can connect from anywhere. There is no IP-based rules at the moment. This is an interesting aspect. We can discuss it to see if it's really necessary to add. For any more questions, you're welcome to reach out to us in all our support channels, which will be presented by Gary in the next slide. I think that's all the questions. If we don't have more, we can move on to, I can hand it back to Gary.
Okay. So thank you, everyone. I hope you found this quite informative. And we welcome you to try out EMQX Serverless today. Just do what I did and go to emqx.com, click on Start Free, select EMQX Cloud, and then you can select Serverless. And you're welcome to join our EMQX community. You can find us on Discord, on our GitHub forum. And if you want to see the open source product, all the code is out here on GitHub. So we hope that you enjoyed the webinar. Thank you very much.